So maybe welcome back. Or in last video we just completed all this stuff. That was maybe working with high level AWS Python libraries, or maybe we were configuring our image classification algorithm to maybe work with high level AWS Python libraries. Okay. And now the task is bit different because from here onwards we will try to make one cancer detection, maybe uh, algorithm using TensorFlow. Okay, and that will be the image classification algorithm using TensorFlow. This is how you can conclude it. Okay, so what will happen from here is I will close these instances because this notebook is running right now. Okay, this is in green color. You can see the green color, that means it is running, and again this is saying running 5 minutes ago. Okay, so what you have to do is simply you have to go here and you have to go to maybe file. Okay, this section, this file section, and you have to click it and you have to close and hold. You have to click on close and hold. Okay, so it will close it, and if you want to leave or if you don't want to leave, it's totally upon you. I'm saying cancel, so it will close and halt it, but we will be, maybe we can access the notebook still. Okay, so it will remove this green thing from here. Now it is removed, that means it is closed. Okay, now what we are what we have to do is we have to maybe come up with a solution for making our custom TensorFlow maybe model. Okay, for the image classification task. Okay, uh, here what let me see it is recording or not. Okay, so let's go over this new tab. Okay, let's go over here and come up over here, that is conda TensorFlow p36. Okay, and that's the thing. uh, Now we have to make maybe one more notebook for it. Okay, so let it load, let it get load first, let it load first. Okay, complete. Okay, so let's continue, but before that I will go to this untitled and just have to rename it because it is the fifth notebook, and it is we can name it cancer detection TF. Okay. So what we are doing, we are using TensorFlow. Okay, that's all. So important library first. That will be maybe import both of three. Then we can import OS, and after that maybe we can import time, and after that we can import random. Sorry, import random, and after that we can go for pathlib, or maybe import pathlib. And after that maybe I'll put it over here so that it will be in a thing. So after that maybe I will import TensorFlow, TensorFlow as TF. So here you are not installing TensorFlow, you are using conda TensorFlow p36. Okay, so that's the use of Sagemaker. This is how it helps you. So you need now to prepare an environment for that first. Okay, so import uh, num num3 as np. We are importing numpy, uh, and after that OS bottom 3 random live numpy TensorFlow. Okay. Then we have to import some magic from Keras, I guess. Keras dot pre-processing. Sorry. Okay. Then let me zoom it for you a bit so that it will be more maybe visible for you. Okay. Then we have to import uh, image to array. Okay, that will be easy to maybe deal with images. img, and then from Sagemaker we can import get execution. So we have done it. Then again from Sagemaker, we will dot Amazon dot Amazon estimator. Uh, oh, get image. This is URI. Okay, you need to understand the difference between URI and maybe URL. Okay, then then again from SageMaker we are importing some magic. Okay, dot TensorFlow. SageMaker dot TensorFlow. You have to import TensorFlow. Okay, then from sklearn dot model dot selection import train test split. Okay, I guess this is fine, and then one more magic, and then we can maybe go to after that. That will be SageMaker dot tuner. I will import uh, that is continuous parameters. Uh, uh, Parameters, and after that I will say hyperparameter tuner. Okay, so I will import it. Let's see if there comes any problem. So this will be SageMaker. What is the problem? SageMaker. I don't know what is happening, but maybe this is from. This is not from. Okay, from, and it will work fine. Yeah. Let's see. You can see the star over here. Um, Things are going on. So random again import. What is the problem? From SageMaker, you have to import TensorFlow. What is happening? From SageMaker, uh, TensorFlow, TensorFlow, import TensorFlow. That's the problem, and that will be resolved. Cannot import name conti nous parameters parameter. That is continuous parameters, not parameters. Now everything is maybe good to go. Okay, now what we will do is we are having images in PNG format. Okay, so as you can see over here, if I'll go cancer detection folder and images, now I will go over here. I will open these images maybe for you. uh, so these images have PNG at its last. uh, okay, so you can see this PNG extension PNG. Okay, so they are in PNG. So what we have to do, first we have to convert it into TF record. Okay, there maybe here we are converting them into TF record, and when we were working with MXNet we were converting them into record IO. Okay, so you need to understand when to convert to which type. Okay, so I will say data root, then path live. Okay, path live dot path. Okay, and here I will say os dot path dot join. After that, os dot get current working directory. Okay, and then we have to give it uh, images. Okay, why images? Images is the uh, this thing, images. Okay. OS patch dot join OS the get current working directory. So if I'll say CWD, that is current working directory. That is the correct working, and our current working directory is the home. Okay, we are working on home right now. That's the thing. Well, then I will execute it, and I can see we can execute it. Then I will go for all image paths. All image paths, I will convert that into list. That is the conversion. Then it will come from data root dot globe, and that will be all. Okay, so we will get into, like, we want all. Okay, then again, I will update my same variable, all image paths. Okay, with maybe a list. Okay, so comprehension, I must say, and for that I will say we are converting every path into string, and we are maybe running inside the path of all images. Okay, so taking the path one by one for each image. Okay, so that's the thing, and at the end of the day converting the path into maybe string. Okay, that if that helps, if this explanation anyhow helps. Okay, then I will maybe shuffle it. Okay, I will shuffle all the image paths. Okay, and after shuffling it, I will give it I will make a new variable, that is image count, and I'm providing, maybe I am asking for all image paths, uh, how many images are there. Okay, so that's the thing. So name random. Okay, so that's the problem. Random. Okay, so let me produce some more cells, and after that if I'll maybe try to understand all image paths. Okay, let's see all image paths, top 10, or not top 10, first 10. Okay, so these are the image paths now. Home, EC2. See, I told you this is os dot path dot join. What it is joining? It is joining os dot get current working directory and images. Okay, so inside images, what it is, it is finding for each image. So what is happening? This was the home, current working directory, EC2 user, Sagemaker, images, and inside images, this is the zero folder, and inside that there are different files. That is the class 0. Okay, and this is how the things is happening. Inside the one folder, the class 1 will exist. Okay, the same pattern will go on. Okay, so that's the thing. I guess you can relate, and now maybe if you want to, you can understand the labels from here. But if this is anyhow becoming very hard for you to understand, then I will write small code for you. Okay, so labels, all image labels. I will name it, and then again conversion I will do. I will put that into path live dot path. Okay, and that will be the path. And after that, for which thing we are doing all of this stuff? Uh, I'll maybe, yeah, maybe this will work, or if this will not work, maybe uh, dot parent name we have to add, I guess. Dot parent dot name. Yeah, I guess this will work. Okay, so for what we are doing, for paths in all images, all image paths. Okay, doing it for all image paths. Okay, then what we can do, I can show you all image labels, but for maybe first time. Okay, you can see it maybe for others. 0 1 0 0, these are the image labels. Okay, either the image is can serious or not. Okay, uh, so what we have to do right now is we have to get numpy array containing all the images with their associated labels. Okay, so first I will give channels. Channels will be 3. Okay, and after that image height will go to 50. Okay, and after that image width width. Image width, again it will go to 50. Why? Because we are having three channels, and we are having image, maybe in three channels. What will happen? There will be a width, there will be a height, and there will be channel will be RGB channel, represented at BZR, because in the late, when it when this OpenCV was in progress in its initial phase, then maybe they defined every library, uh, putting in picture BZR, not RGB. Nowadays we use RGB very frequently, so this thing you have to keep in your mind. And if maybe you can ignore this information, okay? Because again we are not getting into maybe computer vision stuff, or maybe image processing stuff. We are only trying to understand maybe how we have to work with Sagemaker, and how a end-to-end pipeline will look like, and how think will maybe roll down the path. Okay, so as you can see, what I am doing is, I'm this is the dataset, and this is the dataset variable, and what I am doing is, I am creating an NP and ND array, where shape will be image count, then that will be image height, then that will be image width, and then the end channels. Okay, and the data type, we have to make sure which data type it will be of. So that will be NP. Uh, Most used data type, uint 8. Okay, that's the thing. Okay, then maybe I will try to write one uh, loop for you. Okay, so for for file in, so yeah, one interesting task for you. I will explain you what is happening inside this maybe loop, and you need to maybe answer down this, below here. Here you have to answer, like, what is happening, why I am doing all this stuff. Okay, why I am using loop. Only by saying the code you will understand. Okay, so don't worry. Just bear with me, and see the code. Enjoy the code. Okay. So for file in all image paths, okay, for file in all image paths, so these are all image paths. Okay, and for file in all image paths means for every component, this component, okay, for these component in all image paths, then I am making one what we can say, a variable img, that is load image. Okay, and inside load image, what we are giving is file. Okay, and after that, because I guess this will be the PIL image. Just I'm understanding you are not getting what is a PIL image, so just leave that thing again. Uh, Understand the code bit, and that's all. So I'm resizing the image so that if there will be any discrepancies, those will be maybe taken care of, and all the images will be of same, maybe width and height. See here, we for resizing I am not giving height and width. Okay, I am giving width and height. So that's how these things happen. I told you, when these things were in their primary stage and people were building these things, so these are the conventions which were used before. Now you cannot change them, because if anyhow you will change them, so every you have to change maybe every library, and those compatibility issues will be there. Okay, so they have taken this thing as a base thing, and now it is hard to change these things. Okay, so this is a bit maybe more add to your knowledge. Okay, so I guess up till now you are very well in these loops and conditions. So it's totally upon you guys. You will tell me maybe what I have, or maybe what I am doing over here. Okay, so that's totally upon you. Maybe you can ask, maybe you can ask a mentor, and after that maybe you can have a good conversation over here. That will be useful for you, uh, useful for your maybe progress. Okay, so that's the thing. What is the user percentage d over here? And maybe these are the questions you have to search for. Okay, some of the questions you have to search yourself, because these are the uh, pretty much very basic things. Okay, so if you don't know these basics, so it is very hard to maybe why you are here. Then first you have to go and understand those basics. Okay, because I'm taking you maybe line by line through these codes. You will think you are understanding what is happening behind the code, but trust me, uh, mm, it is very hard. Okay, so now I guess you are understanding what is happening. So what I am doing is I was going through each image, and I was converting each image into array. Okay, so after a batch size of 250, okay, it will tell me like after 250 it will add more 250, and it will again print one result, and that result will be images to array. Okay, so percentage d means this is the number, these much numbers. Okay, that's the thing. Okay, so yeah, uh so we have converted this much images. Now we have converted 18 to 50 images to array. All images to array have been converted. Okay, so this that's why I was writing this code. I was converting every array, every image to the array. Okay, so that our model will understand uh, the array more comfortably. Okay, now what I will do, I will give 20% to the training, and rest of the 80% to the test. Okay, so what I'm trying to do is I'm doing a train test split over here. Okay, so x train, then we have x test. Okay, then we will have y train, and then we will have y test. Okay, and then what we will do, train test split.